Let's start with gravitational field intensity topic. So before starting gravitational field intensity, you must know what gravitational field is. So gravitational field is nothing but a space surrounding a material body in which gravitational force of attraction can be experienced. So that is defined as gravitational field. Now we need to come over gravitational field intensity. So whenever we talk about gravitational field intensity, it is with respect to test mass we are taking, or you can say it as unit mass. So we will take it as m, small m. So this is my test mass. Whenever we talk about gravitational field intensity, we talk about test mass. We talk about test mass with respect to a bigger mass, that is our source. Now, what gravitational field intensity is? So, gravitational field intensity is nothing but a force experienced by a unit mass placed at that point. That means force per unit mass. So, this is actually defined as gravitational field intensity. I equals F O M. F here is force and M is test mass. Small m is test mass. Now, as you know that gravitational field intensity, first of all, is a vector quantity and is always directed towards the center of gravity of body whose gravitational field is considered. Now, in this case, we are considering the gravitational field of test mass, this one, and it will be now, as it says, it is always directed towards the center of gravity of body whose gravitational field is considered. Now it will be in this direction, towards source. Now, what are the units of gravitational field intensity? So as you know, we have force. Force is in Newton and mass is in kg. So one unit is Newton per kg and the second unit is meter per second square. And the dimensions you can write it as m is 1, L is 0, T is minus 2. So dimension is m1, L0, T raised to power minus 2. Now, if we need to find the intensity of the gravitational field between test mass and source. So first of all, we need to define force in this case. So according to Newton's law of gravitation, it will be g m small m, and if I say the distance between them is r, so the force will be g m over r square. Now we need to find intensity. So intensity is nothing but force over mass, unit mass. So we'll be writing that. So small m and small m will get cancelled out and you have value gm r square. So this is the general value. This is the general value of gravitational field intensity between source and test mass. Now suppose if I say as the distance r of test mass from the point mass increases, then intensity of gravitational field decreases. As you can see that I is inversely proportional to r square, 1 by r square. So therefore you can say that if you increase the value of r, then we have lesser intensity, lesser gravitational field intensity. So this is the second part. Now the third part says that intensity of gravitational field I equal to 0 when r is infinity. So when we are given with r equals to infinity, then my I value will be 0. They mean that there won't be any field intensity between two objects, that is test mass and source. So if the if the source and test mass is far apart, then you can say that there won't be any gravitational field intensity between them, I equal to 0. Now the next quality is that gravitational field line is a line, straight or curved. It can be either straight or curved, such that a unit mass placed in the field of another mass would always move along this line. Field lines for an isolated mass m are radially inwards. So whenever we have isolated mass, it will be like this. All field lines will be straight line. Now, if I say that we have I equal gmr square, and you also know that it is equal to g value, the small g value, acceleration due to gravity. So we can write, as we know g is equal to gmr square, you can say that I is equal to g. Thus, you can say that the intensity of gravitational field at a point in the field is equal to the acceleration of test mass placed at that point. So we can conclude this by saying this. So we'll meet you in the next session, and that I would be covering gravitational potential. Thank you.